Hi, and welcome to this demonstration of mesh registration. This is new functionality that's being added into Polygonica 3.2. So this is a preview of functionality that's going to be coming out later in 2022, probably September, October. As always, we'd encourage you to follow Polygonica and MachineWorks on LinkedIn. We're putting out more technical information and updates and just general information about Polygonica via the LinkedIn channel. So please follow us and don't hesitate to connect with myself or my colleagues. We'd like to have direct contact with our customers that way. So mesh registration. So the idea of mesh registration is to closely align one mesh with another, and generally speaking the meshes will start off with different coordinates. They could be a long way from each other, different orientations, etc. And the idea is to fit them together as closely as possible, and this is typically used for taking laser scans and aligning them to the original CAD part. The new PF solid register function is based on a geometric alignment. It's not a topological alignment, so it doesn't look at the actual mesh topology and the faces and the connectedness of faces or anything like that. It purely looks at the geometry. And it works really well with partial meshes, fragmented meshes, meshes with holes, etc., and noisy meshes, which obviously is the whole point of it, is to be able to help you to work with laser scans better. You can see the function there, PF solid register, so it takes in a reference solid and a solid, that's the solid to register against, and then the solid to register, and then the result is a transform which you can apply to either solid, or you can use it as something to put into a test system to work out how well the registrations happened, etc. There's also some options, which I'll talk about in this slide. So it's a two-step process. First, there's a quick registration done, which aligns the two models very roughly, well, not very roughly. And then that's followed by a fine registration, which tries to minimize the overall error. And both of those are based on the full mesh, but you can optionally define a reference region. And then in that second fine registration step, that will only focus on the reference region you've defined. So if there's a particular part of the model where you need a very accurate registration, then you can pass that into the API and it'll make sure that that's done properly for you. So you can see the two images of 3D Benchy below. I'll actually demonstrate this later on. But you can see the grey model is the model that's going to be registered, and I've extruded the bottom face, so there's actually it's sticking out below the model. So you can see in the left hand side that's just a general registration, and the fit is pretty good, but it has pulled the result down a bit because of the it's kind of averaged it out over the whole model, and there's that extra bit at the bottom. Whereas on the model on the right, it's the same two models, but I've specified that bottom plane as the area that must be registered accurately. And you can see it's fitted them very, very closely indeed, at the expense of not aligning the rest of the model all that well in the vertical, at least vertically. So you can see there's a big gap at the top, which is roughly the thickness of the extruded plane at the bottom. As always, if you want to ask us any questions about this, or if you want to evaluate Polygonica, you can contact us either on LinkedIn or via the forms on the company pages on the website. So on to the demos. So let's move on to the demo. The first thing to say is that this Polygonica demo graphical user interface is not available to buy. It's just a demo program that we write and maintain internally. So it's just based on MFC, and it's just showing what you can do with Polygonica. So I've loaded in a 1.6 million CAD assembly, and we've remeshed this version, as you can see here, with Polygonica's curvature sensitive remeshing, just to make it look different from the CAD original, which I'm also going to load in now. Load that as the tool. I'm going to load in a moved version of that. just find that in. So you can see they're quite a reasonable distance apart, and the orientation is quite different. And also, if I just show the edges on this, you see that this is actually the original CAD part. So this tessellation has been done by the CAD system. So they are different. So we're going to register the, let's just turn all the edges off that one and turn off the errors. So we're going to register the remesh part against the original part. So if I switch to this tab and just click register, so the whole registration process is going to take about 6 seconds, I think. Yes, that's taken about 7 seconds, you can see at the bottom there. And then if I zoom in, you can see that we've got the two parts aligned. And if I hide the target part, you can see there's the original. Oh, sorry, there's the remeshed version. I'll just show you that. So there's the remeshed version. And then show the target part, and they're the two on top of each other. So it's not quite exact, but it's pretty close. So I'm going to undo that and go back to the original location. And now we're going to mess around with this model a bit. Actually, I'll turn those edges off. So the first thing I'm going to do is just add some noise some random noise to the vertices, just to try to make it look a bit more like a laser scan. Okay, it's just for the purposes of a demo. But there you can see we've randomized the vertices, so it's really quite dramatically bad now. I think most laser scans are hopefully better than that. And we're also going to blow some holes in it. So there's 100 holes. Let's try max rings 25. So I'm just going to randomize 100 holes with 20 rings, which is, it picks a point and then moves out in rings around that, so it grows the hole progressively outwards. And you can see now we've added quite a few of those. The green lines are the hole boundaries. I'm just going to click that button a couple more times. Just make it really bad. Maybe let's add a few really big ones. That's 50. So again, I'm trying to simulate the effects of occlusion in a laser scanning process, although obviously it's very rough and ready. We do obviously use real parts for testing, but we're generally not allowed to demonstrate those parts to the customers. Generally want us to keep them confidential, so that's why I'm just faking this. So that looks pretty bad now. I guess it could be worse, but there's a lot of holes in it. Actually, yeah, sorry about this, I'm going to go for a few more. Let's just do 100. I think my randomizer tends to not be as random as I'd like it. Now we're getting somewhere. Now we can see that there's quite major decimation on the mesh there. Okay, and then let's see what the registration does with that. So also pretty quick, and you can see that it's not done too bad a job there. You can obviously see, in fact, it's almost in some places possibly better, I don't know. Hide it, yeah, so that's what we're looking at. And if we do an analysis of the two, analysis mesh of the two, just to see how close they actually are. Takes a few moments to generate that because there are quite a lot of polygons here. So you can see it's mostly green. We've got fairly loose tolerances. So if you look at the size of the part, it's 236 by 330 by 369, and these measurements here are 5 and 3.5. But let's make them a bit more reasonable. Pull them down to say about 1 unit in each case. Okay, and you can see obviously there's a lot of error due to the vertex noise that I added, and there's maybe a slight bit of systemic error as well, in that it's possibly slightly out there, but it's still not a bad registration given the fact that they're two really quite different parts. Okay, so that's the end of that demonstration. So we'll now switch on to a dental scan. Teeth. So here's a fairly typical dental scan, and I think I've got a moved version of that. Let's have a look. Teeth moved. Okay, so differently oriented, etc. So I'll just quickly register those two together, and you can see that didn't take very long. If I hide the target, then I've got the tool. I've got a bit of Z fighting there, and again I can just check how close that fit is. We've got some pretty small numbers here, so you can see the tooth itself is 63, 32, 62, and it's these deviations are, you know, 1/1000th of a unit. So realistically, there's not that much deviation at all between the fit. It's a pretty decent fit. So let's undo that, and I'm just going to do the same kind of thing. Let me show edges. Yeah, let's remesh that. And so what shall we remesh it? I don't want any sharp edges. What should we remesh it to? Maybe 0.1. Let's try that. Okay, so that's a nice fit. And then again, let's add some noise to that. And then let's just bomb some holes in it. Okay, that's okay. That's got rid of quite a bit of that. Let's go one more. Yeah, so we've not got much mesh left now, but it should hopefully still do a reasonable job. And you can see, yeah, it's registered that pretty quickly, 1.3 seconds. Let's just see how close the fit is, and obviously we've got the noise there, so these numbers are much bigger now, so the fit isn't as tight as it was before when we were in effect measuring light with light, but that's still a pretty decent result. Sorry that it looks a bit decimated on the screen. Okay, so that's the end of that demo. So now I'm going to show you an example of using a highlighted region, or specifying a region to guide the registration. So I'll just load in 2 copies of the famous 3D Bencher model, and let's select base here, and then I'm just going to do an offset of about 3 units on that base. So there we've added a kind of extrusion to the bottom. So then if we kind of line up horizontally like that, and then register the 2, and you can see it's fitted it pretty well, and it's managed, but it's kind of ignored the fact that the base is there. The base hasn't given it enough weight to kind of modify it too much. If I actually hide, sorry, what am I looking for? Hide that one. You can see here that they're pretty close. The bottom, it's managed to get it fairly close. There is a bit, it has affected it a little bit, but not too much. Okay, and then if I just undo that registration, just highlight the bottom of that. Yep, there, and then let's look at it back from the side. So this time it's going to do the rough fit and then the fine fit, it's going to focus on that area. Let's try and get it sideways on so you can see that. So you can see in this case, it's fitted the base pretty well, which means the rest of the model has been shoved upwards. Again, if we zoom in and which one do I want to hide? Let's hide the target part. Then you can see that it's aligned pretty well with the base there. Okay, so that's the specifying a region to register against option. On to the next one. So I'll just finish off with a couple of models that are similar but noticeably different in one or more than one area. So we've got two pipes here. I'll turn off the highlight errors and then just register them. And you can see that, oops, excuse me, you can see that actually the valve on the pipes is in a different location, but the registration is still pretty good. And if we do a difference there, let's just take these values down a bit. So you can see that there's actually a pretty decent registration being done on that, even though there is actually some fairly significant different geometry. So let's get rid of that one. And one more. Let's look at this bracket. Bracket before and after. Let's load in bracket before. And let's load in bracket after as the tool. Now they're already in the same place, so I'm just going to move one of them away a bit. And if you see, you can see here that there's an extra hole in that one that isn't there. And then also this one has a kind of blend chamfer here. So let's just mess that about a bit. Oh, sorry. Just change the orientation. Okay, so they're quite different. I'll push it up that way for what it's worth. And then let's register them. And you can see the registration's not bad. And if we turn on the difference display, you can see, yeah, that's where the hole is supposed to be, and that's where the chamfer is. But let's tighten that up and look at the registration as a whole. And it's done a pretty good job on that. I mean, it's 168 by 40 by 111. Make it tight as steel. So there's a little bit of systematic drift there, but it's not bad at all. And these are quite tight tolerances. And the two parts are fundamentally different in key areas. Okay, so that's the end of this registration demo. We're still working on it, it'll still be tested, but we're pretty confident it can be released later this year. So if you've got any questions or you want to try it out, then please get in touch again. You can contact us either on LinkedIn or you can contact us via the Polygonica website. Thanks for your time and thanks for listening.